Welcome to The Bottom Line Up Front, the podcast that cuts through the noise to deliver distilled insights from today's most important technical webinars, presentations, and demonstrations. Designed for federal and military IT leaders, each episode breaks down complex technologies into mission-ready takeaways so you get the key points fast. Whether it's cybersecurity, cloud architecture, or emerging defense technologies, we highlight what matters most and how trusted integrators like ATPGov can help implement and operationalize these solutions across your agency or command. No fluff, no filler, just the bottom line up front. Today's episode is all about AI systems that actually work in federal environments, not just lab demos or commercial hype. We're breaking down a deep technical session with vast data, looking at how modern AI workloads are reshaping the data stack, from storage to databases to real-time AI pipelines, and what that means for DoD, IC, and civilian agencies that care about security, scale, and automation. First, we have to talk about the problem that the government is actually facing.
If you had asked us in 2023, I would say majority of our opportunities were based around this concept of universal storage and being able to collapse tiers of data within a data center. Today, that has pivoted tremendously towards the AI side.
Federal agencies are no longer struggling with, quote, how much storage, but how fast, how current, and how actionable their data really is. And that's because AI has shifted from batch model training to real-time inference and retrieval, also known as RAG. And the government use cases now demand near real-time ingestion, continuous updates on knowledge bases, and thousands of concurrent AI agents.
But as we move into utilizing those kinds of, as I say, applications, but the AI implementations, it really changes that it's not batch oriented. It's got to be real time. As things get updated, these RAG pipelines and so forth that we'll talk a little bit about have to be very, very current, meaning within seconds of new documents being added to a realm, being able to utilize those in these workflows. Very different requirements as we move into this inference era. Maybe tens of thousands of agents will be accessing this stuff, and it really changes the whole dynamic of what's required for computing. And that's really what we are bringing to the forefront.
Existing legacy architectures weren't designed for streaming inference pipelines, multi-tenant AI workloads, or zero-trust data access at scale. And this is where a lot of agencies get stuck. They don't fail on GPUs or models, they fail on data movement, latency, and security boundaries.
It's a very different conversation than what capacity needs do you have or what feeds and those kind of things. So we're really getting away from that quite a bit, especially talking about the AI workflows as everyone's trying to figure out how to do that, and we can help to simplify a lot of those. So I want to touch on the DASE architecture in case you're not familiar with this. As I said, it's a unique architecture. It's very different. Some of the limitations that even a scale-out architecture built on HA pairs has were kind of glaring. And that's where the VAST system filled all of those gaps, if you will. This architecture is very different in the obvious part of being shared everything. And what that really means is that if you think of a controller-based implementation, controllers manage disks, right, or flash in our case. And so we don't actually have that same relationship.
So what does disaggregated and share everything actually mean? VAST DASE architecture fundamentally changes how performance and scale are delivered. In plain technical terms, that means C nodes handle protocols and compute, those being NFS, S3, SMB, Kafka, NVMe, and TCP, while D nodes store state and data with no controller ownership and no HA pair bottlenecks. This also includes NVMe over fabrics, connecting everything at low latency. And storage class memory absorbs write pressures, and QLC flash is used efficiently and gently for long-term data. Having an understanding of storage and integration experience really matters in this conversation because mapping mission workloads to performance profiles while avoiding over-provisioning is an extremely important part of this implementation. You do have to consider independent scale of performance versus capacity, simpler life-scale management, and fewer architectural choke points from long-term mission systems.
But we're all kind of in it together and kind of creating this whole vision for kind of simplifying AI. And just from a little history, the company was started in 2016. The whole idea was this revolutionary new architecture for storage and for storing data. It was really all about the data, which is why we're VAST data and not VAST storage. Storage is a thing, but managing the data and making data useful is what we're all about. The idea behind VAST was to create this new architecture. We call it DASE, the Disaggregated and Shared Everything. And that was kind of counterintuitive to every other storage company because they were all about shared nothing implementations and still are today.
While talking to Vast, we also saw a shift from the quote storage platform to the AI operating system. Because Vast has said that they're not trying to win on storage anymore. It's all about collapsing multiple AI infrastructure layers into a single operational platform. And their latest platform expansion includes unified data stores at the file, object, and structured data levels, SQL and vector databasing to allow for massive scale, Kafka-native data streams, and data engines that leverage functions, triggers, and event-driven automation, while agent engines and insight engines use NVIDIA NIMs, GPU-assisted embeddings, and inference workflows. So what that means for your environment is it eliminates brittle multi-vendor pipelines, reduces security accreditation scope, and enables real-time AI reactions to data retrieval.
And most importantly, between all of these sync engine, insight engine, agent engine, having the same security. So having them on this single data platform allows us to manage who can use what agents, which users can go out and do inferencing or embeddings and things like that, and make sure that those insight engines and agent engine components can get access only to data that the user is allowed to have access to. And so that's one of the clear differentiators.
But I also want to highlight some non-hypothetical use cases that we discussed with Vast and the expansion of its new platform. Those include cyber network security. The new Vast platform includes AFRL packet capture and net flows, instant pivot from metadata to full packet, reduced Splunk licensing footprints, and faster zero-day investigations. Secondly, we talked about citizen and analyst AI assistants. We discussed a recent IRS chatbot example and continuous documentation updates. Thirdly, we discussed multi-tenant agencies and how the Vast platform is a shared platform with logical isolation, cost amortization, and role-based and attribute-based boundaries.
In this example, I'm going to use some S3 buckets, and I have set up some triggers so that something gets dropped into the S3 bucket. I can see that as a trigger, and that's where we use our Kafka engine internally to impact that and basically execute a function based on that. With the insight engine, function could be to call out to a GPU and do vector embeddings or other things. So the idea is that within the Vast data platform itself, we can now create triggers and functions, minimal coding required. Most of this stuff is written in Python, but it could be written pretty much in anything. All we need to do is take that code and put a Docker wrapper around it, and now we have a Docker container that we can execute as a trigger or a function. Once you create those elements, then you can actually go in and create pipelines.
And that leads us into a conversation about zero trust, ABAC, and security realities. This particular part of the discussion emphasizes where AI platforms fail in government today when security is bolted on later. And this is why Vast's new architecture bakes it in from the beginning, because it includes native RBAC and ABAC, Active Directory integrations, metadata-driven access controls, zero trust principles embedded at the data layer, with the same policies distributed across AI agents, databases, object storage, and pipelines.
As far as the data store and the database, that's kind of where stuff is stored. I didn't talk too much about the data space, but that gives us the ability to have this global namespace. So I have maybe something in Amazon, something in Azure, something on-prem. We can share data across those different realms, have that as a single global namespace, and again, manage the security across that, move data only when necessary, give access to data across wide area networks. So we actually handle about 99% of the zero trust without any external software. It's all built into the Vast system. So there's a lot of security components built in, but ABAC is a core component of our security infrastructure and how we manage that and allow capturing of lots of different metadata and giving it specific attributes based on need there. So.
In our view, this is where Vast really adds value in validating these controls against RMF, DoD zero trust scores, and agency-specific security overlays. So in the end, the AI accelerates approvals instead of blocking them. So what's the bottom line up front of Vast's new AI operating system? It's all about data architecture, security, and operational simplicity. Because federal AI isn't about flashy models, and platforms like Vast show what's possible when storage, databases, streaming, and AI pipelines are treated as one system instead of six. It means that AI's success in government is a data problem first. DASE architectures remove scale and performance bottlenecks, unified platforms reduce complexity and accreditation friction, and real-time AI requires event-driven data pipelines, while ABAC and zero trust must exist at the data layer. And in the end, success in this arena still depends on integrators. Integrators who understand federal networks, zero trust, and mission constraints well enough to put this tech to work. So if you're exploring AI platforms, data modernization, or zero trust alignment, and want to understand what actually works in your environment, reach out so we can help translate VAST's new architecture into real mission outcomes. Be sure to reach out to ATPGov today at www.atpgov.com or email info@atpgov.com or check us out on social media on LinkedIn. Thanks for listening, and be sure to subscribe to The Bottom Line up front wherever you get your podcasts, and stay tuned for more distilled insights from the front lines of tech and national security. So until next time, stay secure, stay mission ready.